Well, good morning, good afternoon, everyone. Thanks for joining us today. This is part of our ongoing series of CESMII Smart Manufacturing Innovation Platform training. My name is Jonathan Wise. I'm the VP of Technology here at CESMII and mostly focused on the architecture for the platform. And I'm joined today by two members of Savigent. Savigent are members of CESMII who have contributed to the platform. In particular, their workflow engine, which is a powerful orchestration layer. So the bulk of the content today is going to be diving deep into workflow, how to build those workflows, how they execute against the platform. On the next slide, Mark, if you don't mind, just a brief word on positioning. We have these kind of three layers that we talk about, all enabled by profiles, which create a consistent interface between the layers. In this slide, we position workflow up at the app level, but it's really a lot closer to the core because it does some things that a typical app can't do, like orchestrating other apps. So that's what we want to dive into today, the ability not just to get access to the data, but to work with it, to work with disparate components and orchestrate them together, and hopefully dive really deep. Just before I pass the ball over to Mark and Jesse to introduce themselves, a few words on Q&A. We'll have some logical kind of breaking points in the presentation. It's going to be a lot of hands-on in the software. So I'm going to tend to batch up the questions until then. Please use the Q&A panel and I can see them coming in. If I see a question that's really pertinent to what's being talked about at the moment, but we'll pause and address that one. But we will try to get to all the questions. If we make it through the 90 minutes and something is unaddressed, we'll circle back with you. If you can use the Q&A panel, we'll be able to track it that way. So Mark, over to you.
Great. Thank you, Jonathan, and greetings, everyone. Happy Thursday. I'll advance our slides here. There we go. I'll do a quick round of introductions, provide a little bit of history and overview on kind of what this thing that we call Savigent is. I'm going to try and keep the slides and overview and history to 10 minutes or less. And then spend as much time as we can in the tool and actually seeing it work. A couple of quick introductions on the voices you're going to hear today. Jesse Strom is our solutions architect at Savigent. He's been with us for 12 years. I think Jesse's worked with just about every customer we've had along the way. He's also one of our instructors, so he teaches classes. I'll tell you, he's a master at applying our technology, and you'll hear from Jesse here in a little bit when he starts to drive the technical demo. I'm Mark Besser, part of the customer success team at Savigent. Really, as kind of title states, responsible for how the technology is used in the field and how our customers apply it and how we make them wildly successful. I'm on my 7th year at Savigent and really been kind of our lead evangelist, if you will, in the industry and the space, whether that's MESA, SMLC, CESMII, et cetera. So with that, let's pivot into the slides and we'll get started. So who is Savigent? I'll tell you, we got our start back really in the early half of the 1990s. And, you know, while we call Minneapolis home base, our work, our customers really take us all around the world, all around the planet. So, you know, you can see we're in a lot of plants around the world, 25 different countries plus at the moment. The technology that you're going to see today was really born out of a long-term relationship that we've had with Seagate. 25 years ago, they were looking for IIoT connectivity to their shop floor, figuring out how they could mobilize data, do some event detection, and put some automation to really responding to the real-time activities and events that were happening inside the plant. weren't really pleased with what was commercially available at the time, and thus the opportunity and Savigent was born. I'll tell you, the technology is really purpose built for the demands of manufacturing. So when you see some of the things that we've done, some of the areas where we interface, interact, and the activities that we orchestrate, I hope you'll get a feel for that industrialized nature of the technology that you're looking at. I'll also tell you that it's extremely flexible, and that is sometimes our opportunity and our challenge at the same time. There's really no problem that we can't solve with workflow and work automation when you think about it. We try and drive that opportunity really into a highly configurable environment, meaning make changes to configuration items as opposed to having to rebuild or recode to get work done. And I think you'll see that as we kind of highlight through the way through the technology. Um, a little bit about our background with CESMII. I think we think our goals and mission align very well to where CESMII's going and where CESMII's headed. How can we take the learnings, the skinned knees, the trial and errors, from the thought leaders in this manufacturing sector, and productize all of that knowledge and really make it available to all the small and medium-sized businesses out there, but do it at a scale and cost that really matches their business conditions. We're aligned to that message, and one of the cornerstones of our technology is this notion to scale up or scale down to meet the complexity of the environment that you're in. We're working on the structure to expose the technology to all who want to experiment, try it, theorize, ideate. So and do it in a way that's supportive and an easy to access environment. And we'll talk more about that later. You heard a little bit from Jonathan about where we fit in the CESMII stack and that architecture. That there's a lot in this thing we call Savigent, which we'll see in a second, but we tend to be synonymous with workflow and work automation. And for trivia junkies out there, a little bit of CESMII trivia. Savigent was the first national member of CESMII. So what is Savigent? I mentioned, we've been somewhat synonymous with workflow, but there's really a lot into this platform, or a lot more in this platform than just workflow. And I'll also tell you that workflow is one of those terms that has a lot of different meanings to different people. So my intent really in the next few slides here is to show you what Savigent does, how the components fit together, and some of those challenges that we've solved along the way. So first, let me start with we're really an action and event-based technology. So everything is based on this idea of an event fired, an event happened, and action is actually needed. Events can come from lots of different places. They don't have to be inside our technology. We can be called from external sources, external technologies, and we can also be managed entirely internal on our own, monitoring, watching, and waiting for those events to happen. So what you're going to see is all leveraging, taking advantage of this notion of being event in action under the hood. So with that as a backdrop, I'll really start in the upper left. The first stop in our journey in the Savigent platform is connectivity. So part of our platform is really focused on data producing assets and how we mobilize data. We leverage a profile approach that is strikingly similar to the profiles that Jonathan and the CESMII team talk about. What asset are we talking to? What communication method are we going to use? What data are we mobilizing? What contextualization needs to happen along with that data to make it more valuable downstream? Those are some of the things that come into play when we talk about our profiles and our connectors. Those are all functions we perform. We're not limited in kind of who or what we interact with from a read or a write perspective. whether that's hardware, machines, PLCs, sensors, systems, databases, people, mobile devices, etc. Generally speaking, I say if it draws power and throws off data, there's a pretty good chance we can connect to it and mobilize data. Um, we've pre-built a lot of these connections, which you'll see here in a little bit. We make those connections available via our artifact library. So this notion of reusability of assets and prior work is a stalwart of our technology. It's a foundation of what we do. This connector strategy really allows us also to build solutions that are not, I'll say, directly dependent on traditional integration, meaning that when we build this flexible, reusable architecture on how we interface to assets and devices, we do it in a way so all the workflow solutions that we have in place that sit above these data connections or below these data connections all continue to operate even when you decide to change technology. So I swap out a sensor, I swap out a PLC, I swap out a plant control system. When we do it right with this reusable architecture, you can unscrew one of those, screw in another, and all the workflow and work automation still continues to operate the same way. So hugely advantageous for enterprise customers who have a pretty dynamic IT environment. So now we got plugged into assets, we got data moving. The second stop is really the operational insights. How do we start to look at data? And that's our data historian stop. Um, there's lots of historians out in the marketplace. I think of really a couple of features when I think about maybe what makes our historian a little bit different. First of all, it's a scale up, scale down kind of environment. So I mentioned earlier the ability to scale up to match the size and complexity of a major enterprise, or scale down to a site that maybe only has 1, 2, or 3 employees working at it. That opportunity to move up and down from a processing perspective is embedded in our technology and in that historian. Also, it's very lightweight, so we can place it close to the action. That enables us to facilitate some remote connectivity. Don't have to be hooked up to the mothership. We can keep transactions flowing and synchronize when we've got connection reestablished. The other feature is really this notion of rich metadata that comes along for the ride. So back to this event-driven technology that I mentioned, because of that, because of the nature of how we do it, what comes along with events and actions and activities is everything that you'd want to know about that step or stage in the workflow. Who did it? How long did it take? What were we working on? What was the state that we were in when we executed on that? We know all those details about individual steps as well as the entire workflow, and we expose all that data from an analytics perspective. That notion of state is really important and is a huge value for us. If you think about maybe a 2-week long production run, and then keep in mind that we're historizing all that event data, we know the state of the environment at any given time, at any given point in time. So it's very easy for us to go back from an analytical perspective and see what happened, what was good, what was bad, what was working, what didn't work. So this notion of using it to remediate and fix issues, trend out and look forward, or even use it as a golden batch are really inherent functionalities of using that historian. Third stop in our journey is now that we've got data and we've got it moving and we're looking at it and we're learning, how do you start to monitor and measure and watch what's happening inside the environment? And this is the real-time data stream monitoring sensing engine that we have built into platform as well. So it watches and listens for conditions that happen inside the environment. I'll tell you, any variable, any tag, any data stream that we can see, measure, and watch, we can use from this, this technology perspective. So if I want to watch when an amp load or a power draw on my extruder is starting to trend up, along with fluctuation in temperature at the head, And I want to note if we're 10,000 feet into a production run of maybe this particular pipe, those based on historical knowledge are all leading indicators that I'm probably going to have a head failure sometime in the next 24 hours. So we can watch for those things to happen and then jump into action when time's appropriate. Um, uh, we're not limited to inside the firewall, so we could be touching, listening, watching data streams that exist inside the enterprise, or we can combine data streams that exist outside the enterprise as well and bring them all together. So these three pieces in the portfolio lead us up to the last stop, which is workflow. So now that we have the data, we're starting to get some intelligence. We're doing some conditional monitoring. We're watching for things to happen inside the environment. The last stop is really the so what in my book, which is, so what do we need to do about it? What's the action, right? What needs to happen? And that's really our workflow engine. Um, I'll tell you, it's rich, it's robust on the things that we can do. It's not limited to scientific calculations or basic notifications. We're talking about real-time orchestration of things that are happening on the shop floor. So whether we're changing database or system values to reflect changes in status, whether we're orchestrating unconnected or unnetworked work cells on the platform or on the shop floor to make them work in harmony with each other, adjusting set points, changing recipes, updating PLC configurations. Those are all in the realm of things we do with workflow. So again, anything we can see or measure, we can impact with workflow. And I'll bring back this idea of library and reusable components again, and we'll continue to talk about it here in the upcoming slides. But what are the things that we start to build, see, use, and do with workflow? And we'll give you a little bit of a flavor of what some of those are. Functions, communication methods, protocols, profiles, actions, events, triggers, blocks of work, all become reusable components that we'll leverage inside the workflow workbench. And Jesse will show you that along the way. So now that you got a little bit of what Savigent is and what we do, how do we get started typically? So I'll tell you that generally speaking, we start with an idea. An operations person, an engineer, is usually starting a sentence with "I wonder." I wonder if. I wonder. I'm theorizing. I'm postulating. I wonder if there's a correlation between ambient temperature in my plant and production quality. I wonder if I could gain some efficiency in how we do changeover process, because it feels like we don't really have a good standard or a good way to measure the time we're taking, and I think it's skewing my throughput numbers. I wonder if I could automate these tasks somehow so I could free up my operator to do blank and fill in the blank. Fill in the blank. That ideation usually leads to a stop at the library to say, what kind of things have we already built? What kind of Lego blocks do I already have that I can leverage and repurpose? And then that usually leads to a design, and we start snapping and building the blocks that we don't have and put them together. And, eventually we end up with a solution to the I wonder problem. If we take a look at what some of those Lego blocks are that we talked about from a reuse and a library perspective, there's lots of different flavors to these, and this is not an exhaustive list, but really meant to kind of show some of the good work that's already done and available to jumpstart process. But whether we're talking about communication methods and how we facilitate the handshakes to those assets, that work's already been done. Those agents and those artifacts already exist. And Jesse will get in a little bit of terms here, but you could think of agents as really being one of the smallest of the Lego blocks. So functions with inside of functions that we want a standard way to facilitate or a reusable way to facilitate. So whether we're touching historian or database or other files or doing calculations or statistical analysis or manipulating file structures on servers and systems, managing time, managing resources, or even exposing the technology to direct scripting, C# command line type interface. All of those agents and building blocks are already done for you so that you can actually leverage them. As we start to think about, assets and solutions that exist, I think about kind of the Purdue model, and I group these together a little bit, but, having been at this for 25 years, there's a lot of things we've already seen. So a lot of technologies that exist on the shop floor, machines, work cells, and PLCs and sensors that we have experience in connecting to, and have built a lot of those connections and expose them and make them available. On the same token, as you work your way up the food chain, whether you're in that MOM or MES layer in the middle, or you're at the enterprise application level, we really find ourselves playing in all of these spaces and surrounding and supplementing these technologies with a level of automation that wasn't necessarily purpose-built or built into any one of those specific technologies, or done in a way that brings harmonization across all of these technologies. So what kind of problems do we solve? I mentioned earlier, when you start snapping all these Lego blocks together and leveraging the core components of Savigent, being how do I move data and connect to data? How do I get operational insights from data? How do I watch and listen for events and actions and activities to happen inside the environment? And then how do I react to it when I'm aware of it? There's a lot of things that we can build with it. So again, not an exhaustive list, but whether we're working on workforce productivity or driving a level of SOP and standards to safety and sustainability, we cover a lot of ground from a solution perspective, and happy to share more details on those, if folks have questions. I'm going to stop talking and I'm going to hand this over to Jesse here in a second, but a couple of kind of guiding thoughts here as we're moving into the technology side of the equation. Please keep in mind, this isn't meant to replace training. We will work to make full training available to those who want it, and we'll provide some details on how to make those arrangements and make that happen. We're going to try and compress about 4.5 days worth of training and material into an hour. So we're going to cover a lot of ground in a short amount of time. So hopefully give you enough flavor on what you're seeing, or at least enough intrigue on what you're seeing to want to see more. Would love to have you draw your comparisons to the tools and the technologies you use today. We love to hear that feedback on kind of how it stacks up. Would be great if you guys had this, or how do you guys do that? So happy to listen for and take all of that feedback along the way. And then I'll say, look for the concepts that I talked about in the prior slides. So this idea of pre-built Lego blocks and artifacts and assets that jumpstart development. So with that, I'm going to stop talking, and Jesse, you're up.
Thanks, Mark. So my name is Jesse Strum, and I joined Savigent Software back in 2008. So like Mark said, I've been with Savigent for just about 12 years now. So I'm part of the solution architecture team, and I work with both our existing clients and our future clients to support pre-sales activities and lead training classes and help drive implementation plans and roadmaps for our customers. Like Mark mentioned, this is a kind of a crash course, so we'll be going pretty fast through the material. But feel free to type those questions into the Q&A chat there so that we can get them answered as we work through the content. I'm going to start here with terminology. So let me share my screen. One sec. All right. So just to get us all level set and we're kind of speaking the same language, I'll go through some common terms that I'll use throughout the demonstration so that you know exactly what we're talking about as we step through the different areas of Savigent. Just to start with, system management is the tool that hosts all of our different plugins or our kind of specific sets of functionality. You'll see there's a handful of items up here that align with the different product components that Mark was showing earlier. Today, we'll really be focusing on the workflow piece, so the workflow designer, workflow deployment, and the pieces that feed data in and out of that, so the models and the engine designers as well. Like you can see here, there's a lot of different plugins in here that'll help you with historical data analysis with Streamline, as well as deployment and management of the system, but we'll focus on the workflow as we're in here. One big piece that you'll see as we move through the product demo is this reusability concept. So throughout you'll see this concept of, okay, we're going to create a definition, and then from that definition I'll be able to instantiate it as or basically create a copy of that definition as I get events or reuse that asset. So for an example here, the couple definitions that we have is, all right, a definition is a template with some sort of default configuration. This could be a connection to, let's say, an OPC server. And then when I instantiate that connection to my OPC server, I have to provide something like the IP address, right? So that's going to be my specific configuration. And I can instantiate connections to multiple OPC servers. Each of those would have their own specific configuration. So that would be an instance of that definition. So that's going to be a common theme that you'll see throughout model designer, the workflow designers, and engine designers as we step through that here today. Three big components that we'll talk about that comprise workflows are events, actions, and user actions. So an event is really an occurrence or a moment in time. It can be used to trigger a workflow, or that event could carry a payload, so some data set that goes along with it. That sort of data that's carried in an event is called an output. Any of the elements that you see here that produce data for a workflow to use is called an output. So in an event, that'll carry an output. An action may carry an output. A user action may as well. An action is going to be an automated capability that's going to execute asynchronously from the workflow, and it may have its own set of inputs and outputs. An input is data that's going to be provided from the workflow to an action to execute. So if our action is, let's say, to retrieve some data from a database, my input might be the key to that data inside of the database, and the output would be actually the data that was retrieved from that database. You can apply that same example to a user action, but instead of a database, it's a human that's there. So I might give that human some information that they need to make a decision, and then they can provide that information through some sort of portal, typically a web portal, but other smart devices like tablets or scanners can be used as well. Savigent supports the ability to direct these user actions to certain people directly or to users based on their roles. So this would be something like an operator role or a supervisor role. We could send information from the workflow to that specific group of people, and someone could act on that piece of information. Inputs and outputs can be comprised of data types that allow us to create sets of data or enumerations. For example, I could create a process order inside of my model that might have information such as what product I'm going to produce, maybe a list of a bill of materials, so what materials and the quantities and the formulation I'm going to use. That will all be part of my data types collection, because I could use that same data type throughout. So I might have actions that are working with a production order or a user action or an event. And that way I can reuse that data type throughout the model as I basically model my external systems that I'm talking to. On the engine side, this is where we're actually doing the connectivity to these external systems. So a couple quick terminology pieces here. Agent, Mark showed you a kind of a list of the small Lego blocks where we talked again about OPC UA, Kafka was in there, as well as TIBCO, different databases. Those will provide a way to connect to these sort of systems. And what I'm going to end up doing inside of the actual module is I'm going to take that agent, and let's say I connect to an OPC UA server and I get some data that's like 10110, right? I want to convert that to something that's model ready or workflow ready. So maybe that means my wafer is loaded inside of a chamber, or maybe that means that my machine is aborted. So that's basically what's being handled inside of my module. Is I'm using agents to connect to my different data sources and then help translate that data into something that the workflow and the other tools can use. So once I've done that, I can also tie my modules together essentially into a folder called an entity. So this could be a group of, let's say, my modules that are communicating with some ERP system. I might group those all together. I might have receiving orders module, a production order module, and a shipping order module, kind of some basic functionalities of a manufacturing plant. I could tie those 3 modules together in essentially a folder called my entity. And then I can put that inside of an engine, and that's what I would deploy as my connection to my ERP system. Every engine runs in its own application domain as a Windows process, and what I can do when I create this engine is actually have multiple instances of it. So if there's multiple ERP systems to connect to or multiple pieces of lab equipment, I can use the idea of the engine definition that I created inside of the designer and instantiate multiple copies of that, each with its own configuration, such as IP address or database connection string. So let me jump into the actual tools here. So the first place where we start is really modeling our external data sources that we're going to connect to. So these can be level 2 systems, like your control systems, or it could be laboratory equipment, or it may even be ERP systems on the level 4 side that I'm connecting to. Anything that the workflow is going to interact with, any external system or asset, will need to be modeled inside of the model designer first. And we have some models that we can start with. So I'm going to pop open a control system model to start with. And this is going to be a pretty simple model to start with so that we can see kind of the basic interactions for how I would group the control system interactions into events and actions. You'll see there are not any user actions here inside of our control system model. That's because we don't have any user interfaces built into this. This is really going to be about events that I receive unsolicited from the control system and actions that I can invoke on that control system. So one action that we see here is to send a process order. So when I use this action within a workflow, I can see I can send a list of process orders to the control system. This will allow the control system to basically have the information it needs to process these different orders for their production. These could be mixing orders, pelleting, grinding, whatever your manufacturing process is. What is a process order comprised of? We can take a look at our data types up here. And we'll end up seeing, in this case, a process order is pretty simple. It's a product ID, a description, what resources this production order is intended to be run on, the quantity and the unit of measure that I'll be using. I'll show you in a little bit some other models that have a much more detailed process order that includes the bill of materials and the formulation. But for our example here, this is a little bit easier to take a look at. You'll notice we also have a result code here, done. So when the connector here through Engine Designer is completed sending the process order to the control system, the workflow receive basically a return from this action that says, it's done. I've sent the process orders. This will allow the workflow to continue to the next step. Now, at some point in the future, the control system will have run that process order. We don't really know when, so that's where these events come in. So at some point, the control system will say, hey, for process order 1, 2, 3, I have produced 10,000 kilograms of horse feed, for example. So that's what we'll see here. It'll be linked to a process order ID, the quantity, and the unit of measure that was produced. I may also receive an event for the materials that were consumed for this particular process order ID. As we can see here, a material is a list of materials. So let's take a look at that data type. So material is the material ID, the quantity, and again, the unit of measure. So that's really how kind of a simple interaction with the control system would be set up. We also have another action that can be invoked on the control system. That would be to cancel a process order, for example. In this case, the control system really only needs the process order ID that we need to cancel. So this could be if our ERP system said, oh, hold up, this order's been canceled, or a supervisor realizes, that they need a hot lot to come through here first. So they might go in there and cancel a particular process order. And then Savigent can communicate that information down to the control system. Now, if we take a look at a model that's more related to SAP, for example, what I might end up seeing is a little bit more detail here in some of this. So, for example, here I might end up seeing, here I have a production schedule. What does this production schedule look like? Well, it has headers, phases, and order items. This order item might have quite a few different indicators, material numbers, quantities, formulations. So these are all of the pieces of information that could comprise a more kind of complex production order. So now you could see why this is created as a data type, because as we use it throughout the different models, we didn't want to recreate this data type every time. So this is really a way for us to reuse a production order that's already been created. So this one's a little bit more aligned with like an SAP system inside of ERP. The last set to show here is some user actions to give you an idea of what those might look like. So if I am assigning a destination for a product that I'm producing, the web page might need a list of storage locations that are available for the product to be put in. The output, or what the user is selecting, is one or more storage locations for a particular product that's been produced to be stored in, and maybe some notes along with that. The navigation control for the user interface is here as well, so they can either say confirm or go back, right? They can say, let me go back to the previous screen. I think there was a mistake. So this will allow the workflow to kind of be guided as it moves through the different pieces or elements inside of the workflow. One thing you'll notice, and this is kind of applies throughout Model Designer and throughout the entire system management product, is that everything is controlled with check-in and check-out. So as a user of this system, I have the capability to check out because I have that authorization, and I can check in and make changes. This is all being tracked by the system. So any modifications to models that are made, the user, their comments, and what modifications that they made are going to be stored and available as a history or a report to view if someone wants to take a look. The models are pretty important because, as you can imagine, once a model's created, kind of developers can work in parallel, right? The person or the developer that's going to end up creating the engine project, the actual connection to the external system, can use this model to start creating a connection for the OPC, for example, if that's what they'll use the control system model for. And the workflow developer can begin creating the workflow at the same time. So what's really binding those pieces together is the model. That's the contract between the different components here. You'll notice that the models are technology agnostic. They're not saying, hey, send via OPC. There's no code inside of here. It's simply just defining the data that's going to be moved to and from the external systems. All right.
Jesse, just before you move on, can I interrupt with a question?
Sure.
Let's say I have an object in my model that has a certain state. Can I fire a workflow when that state changes? So a piece of equipment is running and now it's not running.
Mm-hmm. Yeah. So typically that would be created as an event. So you might have a model that is intended for this piece of equipment. And what you could do is you could create an event that's called machine state change. And perhaps you created an enumeration as a data type, and you can say, running, aborted, idle, some examples. And then inside of the engine, when you're connecting to that piece of equipment, you'll bind the different tool states to the actual equipment. So as it changes those states, those events will be fired. Those could trigger workflows, or if there's a workflow that's paused waiting for this tool state to change, then it could resume.
Great. And a couple terminology questions. What's the difference between an EAI adapter and an engine?
EAI adapter and an engine.
Or maybe just generically adapter and engine?
Sure. So The way that I look at it is there's a couple different pieces inside of creating an engine. There's the actual technology layer. So am I using a web service? Am I using a OPC connection, OPC UA or DA Classic? That's kind of often as I view adapters, right? The connection to that external system. But then there's the intermediate layer really, which is, okay, now that I'm connected to that external system, how do I translate that data into something that the workflow can use, something useful? So in our example that we just talked about, the machine state, maybe 0, like maybe it's an OPC tag we're looking at. And 0 is idle, 1 is running, and 2 is aborted, something like this. What can happen in that layer, that translation layer, is basically convert those into that enumeration data that we talked about, so that the workflow designer doesn't need to care about those implementation details on how the particular tool or machine operates, right? They'll only be interested in the real tool state. There's a few other things that can happen in that management layer as well. Things like keep alive intervals or pings, that sort of data can be buried in that translation layer. Also, let's say date formats, right? There's some data that needs to move from a workflow to an external system. That date time format might be needing to be very specific as a string format inside the external system. We don't want the workflow developer having to worry about, again, those implementation details, so that management and translation from how the workflow views data, which is really easy for like a process engineer to use, into kind of the implementation is handled inside of that connector engine that we've been calling it.
All right. Maybe just there's a couple questions related to the definition of a engine again. So maybe just go over that one more with a little more detail. And there's a specific question about the distinction between a transaction and an engine.
Yeah, actually, I
think I'll let you take it.
Yeah. So, I think we're about to transition into kind of the engine designer section. So I think that'll help clarify a little bit of that. But just again, real quick here, if we look at the control system, so these are kind of events or actions, right? Those are kind of like the transactions. Together, this model comprises all of the components that I could interact with for this control system, for the example. And when we jump into the engine designer here in a minute, what you'll see is the engine that we've created that actually performs all these different elements, these different actions, transactions, events that are there. So, one way that I look at it is an engine basically contains all the different pieces of functionality that I can either invoke on the external system, or the external system can provide back to the workflow.
Awesome.
Yeah, let's jump in that really quick, because I think this will help answer that question a little bit here. So we had started talking about the control system, so I'll kind of continue on that theme. So we have this engine here, this control system engine, that basically will contain those different actions and events that you saw in the model. So what we're looking at here on your screen is actually the send process orders module. And you can see there's, maybe 1, 2, 3, 4, 5, 7 different agents here on your screen, different colors, different shapes, different sizes. That's one way that Savigent visually tells us kind of what's going on inside this module. What I do know here at the end, and I'll kind of move into these are our actual technologies. In this case, this is OPC .NET or OPC XI it was called. So kind of another flavor of OPC communication. And I can see that this is actually the clients to send that information. So when I look at it, there's the various connection information. What's the server URL, the read and write endpoints? What intervals do I want to use to communicate with the OPCXI? And this will start to give us the information that's needed, for example, to send a process order. So this is going to be our management layer, which is a C# scripter in here that allows us to kind of use script code to convert essentially the 0, 1s, and 2s of the world into, okay, this is actually the process order ID, the number, etc. And everything you see inside of here is going to be drag and drop and kind of visually easy to move around. So if I want to connect my message here to my incoming message port, I can just drag and drop that over. Zoom out a little bit here again. So this is just giving us an idea of how I might talk to different, or talk to the control system, but with different actions that I would be working on. So I might cancel process orders or send them. Now, we also said, hey, we might get produced materials and material consumptions from the control system. So this module is actually a little bit simpler. It's monitoring the OPC tags again, and basically saying, all right, when I see certain OPC tags, maybe there's a handshake bit or a synchronization bit, we'll say, oh, great. I know that I can now package that up and I can take that data and send it as an event to the workflow. So you'll see right here, there's an event provider agent that's taking that information and sending that to the workflow. So that, again, can trigger event. That event can trigger a workflow or resume a workflow that might be paused. Same with material consumptions. That'll look pretty similar to what we've seen so far. If I take a look in our toolbox, you'll see these are a lot of the categories that Mark was talking about earlier. I don't have all the agents loaded on here at the moment, but there's OPC agents, Kafka, Serial, TCP, database agents. And when I'm ready to use one of these agents, maybe I'm just going to go to my math agents that I have loaded on, and I can drag and drop a basic arithmetic agent onto the screen, right? And I can basically hook up the operations that I want this arithmetic agent to work on, and then I'll end up getting a result. And I would configure that with the properties, again, that are here. So when we looked at an OPC agent that had properties such as what's the IP address that I'm connecting to, when we look at a math agent, it's more about what sort of math am I using: add, subtract, multiply, divide. So that's how all agents are configured. They'll always have their set of configuration. That's part of them. And then as part of the engine, which is how I'm going to tie all my modules together, that's where I'll be able to expose that configuration as part of my definition. And then I might go ahead and I can deploy that one or many times depending on the databases I'm going to connect to, or it could even be the different control systems and the different IP addresses and connection strings that I need for that. But again, I always kind of start with, okay, I have a model. What do I need? What do I need to do to interact with this system? What actions can I take on it? What events will this system give to me? Then I come into here and I say, all right, I'm going to use some of these agents that I have to set up my initial connection to the external system. And then I'll use my programmable agents because there may be APIs that I need to load a DLL in, or some command lines that need to be run, or what have you. And I'll manage that data, and then I'll provide the conduit to and from the workflow for that information to flow. So that's essentially what an engine will end up being. Now, if we look at from a deployment perspective, an engine will exist deployed to my Savigent system here. So in this case, I have some manufacturing equipment modules that's handling my interaction for the demo that we're doing. I'll also have my other engines such as enterprise or workflow servers that are essentially engines that are supporting the other functionalities of Savigent. So there's an engine here that's supporting the workflows that we're about to see here in a couple minutes. Continuing that theme of definitions and instances, if I needed to connect to another set of manufacturing equipment or a different system, I could come in here and I can create, again, another copy or instance of this particular engine. So I can say, all right, I'm going to select from available definitions that I have inside of Savigent. So let's say I select the manufacturing equipment here, and then I can say, oh, I'm going to just configure this. I'm going to mess with these configuration options, change these around a little bit, and set it up the way I want it, give it a name, and then I can deploy this alongside of that. So I can set up as many instances of engines as I need to support my system. Does that help answer some of the questions around the engines before we dive into the workflow piece?
Yeah, I think so. The next set of questions were on visualizing the workflow. So I think that's where you're headed next.
Yeah, perfect. Perfect. So let me just open up a kind of a simple workflow for us here. So in the interest of time here, I'll kind of run through this pretty quickly, and we'll actually run through a live demo so you can see how the workflow tool is interacting with the web interface and the engines that we've deployed. Let's zoom in just a little bit here. In this particular example, we've kind of created a little check-in truck scenario where in this particular facility, a truck will arrive, we'll record the weight, we'll take some samples, the truck will dump the material, we'll need to take the weight again and then check out the truck. So what I'll do is I'll actually go ahead and I can start this right inside of the design mode. So even though I'm still in the design mode and I can come in here and I can drag and drop different components on and hook them up, I can also just start running this. So what I'll do is I'll jump, let's see if I can dock these screens side by side for us. It might allow us to see things a little bit better. There we go. Zoom out just a little. And we'll just, since this is the receiving bulk, we'll go ahead and start a receiving bulk workflow. So here we go, receiving bulk and truck, receiving bulk and liquids by truck. As we can see in here, we've already jumped through a few different components, such as getting the schedule from the ERP system. And we're actually here on our first user action. Again, the shapes and the colors, those help the user visually describe the workflow that's going on. So I know, since this is highlighted red, that I'm inside of the bulk receiving schedule. Inside here, we see a lot of different schedules. I can sort by start dates or end dates. I'm just going to go ahead and pick a schedule here and kind of move on to the next step. You can see here that we're updating the schedule in the ERP. There's all sorts of details about the purchase orders, the materials that are involved, inspection, required information would be red. The workflow is actually telling the web UI what's required I can see that here in the configuration step. That's kind of the yellow step here. So driver name is required. I can be the driver today. And my license plate is 1, 2, 3, 4, 5, 6. So that will be information inside of here. One cool piece, I'm just going to make this full screen again just for a moment, is that I can actually end up seeing what information is flowing to and from the web UI. So in this case, we're at the display check-in bulk truck step. If I click on this step, it'll actually load the information, such as the different inbound deliveries, wash ticket information, material inspections, all the different details that we saw on the screen is going to appear here for us to take a look at. Now, if I scroll up here, here's my truck, my order number. There's our first delivery item, the ERP code is inside here, our commodity. This is the same information that I'm seeing here on the screen. And what that does is allow the workflow to actually visually show you exactly what information is flowing to and from the screen or any external system in this case. So if I were to look at any of the steps that we had here, I could see the schedule coming from the ERP system and updating there. I'll just kind of step through this. Maybe I say, yeah, I executed my truck inspection. Now we're at kind of the gross weight step, and you can see as we go through these steps, it is being updated here inside of my workflow. A couple other cool components. You can plug in language components if you wanted to see the whole web UI that we're looking at here inside of Spanish. You could do that. For now, my Spanish skills aren't quite up to date, so I'm going to stick with English. And you can see that the information that I have is flowing from step to step. So there's my driver name that I entered earlier. There's my license plate information. Here's my notes about the truck arriving. I'm kind of going through here. At this point, it's waiting for the sample to be taken. This could be an automatic interaction with one of the manufacturing equipment that will come in and kind of grab the sample from the center of the material in the truck. Perhaps that goes to a lab and that can be analyzed right there on the spot before the truck is allowed to dump the material. That can be used for payment information, whether it's grade 1 soybeans or it's I want to take a look at the amount of heat damage kernels or something that exists inside of the grain or manufacturing product that's being dropped off. Finally, we're kind of on the last step here. So this is really a summary of what we went through. Hey, this commodity number 6 from batch 6 arrived. The quality is good. The moisture and acidity are where they should be. Minimum is 0, max is 20 and 15%. I assign my product destinations. It's going to 4 different bins, 25% to each of these bins. Maybe I add this and I can switch it up a little bit. I can also put in my initials because that's required to sign off. Truck is empty. I might end up printing this information, which of course would go back to the workflow and use another external connection to like a printer, for example, to print the documents that might be used for this. That would bring us back to kind of our overall view of work in progress. So if I had a handful of these workflows all executing at the same time, they would show up here. What I can do, so you can see that, is actually go ahead and just have this started and running. So instead of running in debug mode, Now I'm running this in kind of deployment mode. So if I come back inside of here, and I'm just going to go ahead and I'll start receiving bulk here. I'll move it to step 2, which is the check-in bulk truck. And then I'm going to go here and I'll start another one. And I'm just going to leave it at the schedule. So if I go ahead and take a look at the work in progress, I'm going to make this a little bit bigger for you guys to see. You know, here's our check-in bulk truck. Since we've already selected an order, the order is going to appear here. Maybe we don't know what the material is quite yet, but we do know the carrier name. I haven't entered the driver name or the license plate number yet, so these are still not available. But this gives you an idea of kind of where I was. And you can see I closed those other tabs inside of here, but if I wanted to pick up right where I left off, I could say, all right, I'm gonna jump right back to where I was. And now I can start filling in the driver name and my license plate number. Yeah. So that's really what this work in progress page is, a view of all the workflows that are running. And this can be tweaked and changed to be certain users. So maybe as an operator, I only see certain workflows inside of here versus as a plant manager, I might end up seeing all sorts of what's happening on both my receiving bays, my shipping bays, as well as all my production processes. So that's kind of all available there. Now, if I jump back into Workflow Designer really quick, just going to throw up a couple examples. You can see workflows can end up having quite a few steps. You know, depending on how simple or how complex your process is, you might have decisions that are being made, which will require going down various different paths, invoking different actions that you see here, or requiring data from different users. One last cool piece that I wanted to show you about the workflows are, you know, if I wanted to just create a new project, I could come in here and say, all right, I'm going to create a brand new project. Since we've kind of been sticking with the production theme so far, I'm going to say, all right, well, I need my user actions, which are all inside of kind of my manual models here. So I'll add that. And I'll also go ahead and add my my certified activities. Now, we'll call this mixing. So at this point, I'll end up having some user actions that I can use, and I end up having some events that I can use to create my workflow. So it's as simple as coming in here, saying, hey, I'm going to create a new mixing workflow. This workflow, let's see, we call this mixing. So we'll start with the mixing event. And I you know, will first create my transferring instructions to get some of that information here. And maybe I need a short mix, and I need to get some information from the user as well. So everything that you see inside of here is going to be drag and drop. And what's cool about these actions is they could be actions that are implemented within the engine that we talked about and showed a little bit earlier, or they can be implemented in another workflow. So this allows me to bundle up pieces of functionality and reusable components, such as check-in truck, checkout truck. If I wanted to start to bundle those pieces together, I could create a workflow that is check-in truck, and I can drag and drop that on and use that inside of another workflow. So that'll give you the ability to use essentially workflows inside of other workflows. And And that again is providing you that functionality, because I might be checking in a truck and that same process is followed both for my receiving bulk trucks, my receiving liquid trucks, and maybe that same process of checking in a truck is also used for my shipping of a truck or shipping of a liquid truck. So that way I can bundle that functionality together and reuse it as needed. A couple other pieces to mention. You saw the decision step earlier that can allow different decisions or different paths to be taken in the workflow. We also do have the ability to kind of fork and join together. So if you need to execute multiple different steps in parallel, the workflow does support that. So you can both be getting information from a user with a user action, and you could be performing some automated actions in the background. So that kind of provides that ability to interact with multiple external systems all simultaneously. Was there any, I wanted to make sure to save some time for some questions here at the end. Was there any other questions around the workflow specifically?
Yeah, definitely got a few in the hopper for you.
All right.
So we got a lot of folks working on machine learning or predictive algorithms. The kind of the ultimate question here is it possible to send part of the analysis? Let me paraphrase. Is it possible to call out to an external algorithm from within a workflow? So let's say I've got a awesome machine learning algorithm running on a Docker container in a cloud platform somewhere, and as part of the workflow, I want to send data to it and get a result back.
Sure. Yeah, certainly. So I would create an engine for us to allow that interaction, whether that interaction occurs with some sort of cloud interaction, web services. We have Azure agents. So there's probably a few components that we could use to even set that up right away. We would model what that interaction looks like, so that we have the information we need to get the data to the machine learning algorithm, and then we can get that information back and use that information to drive decisions inside of the workflow. Whether that decision is as simple as saying, hey, we need a maintenance person over here on this particular tool because it's going to have a machine down event soon. Or as complex as, hey, this might be a manufacturing defect. We should look at this closer, make sure that we don't have to scrap anything, right?
Right. Okay, so the next question is simple on the surface, but it's really around how the workflows execute. So I'll ask the simple question, and then maybe we can drill in a bit to some related questions on deployment. Can we save the workflows created in Savigent and execute them as a command line through a terminal?
So were you saying save the workflow execution? Was that what that was? Or?
Yeah, boil down this engine to a command that can be run from a command line.
Sure. So essentially, our events can really come from any sources. So if the event to start and run this workflow is going to be invoked through a command line interface, that can certainly be set up. Ultimately, these workflows are executing inside of the Savigent tool set, but they can be invoked or triggered by really any external source. So what we would do would be go into Engine Designer and have that hook available, for the user to trigger whatever event they would want to do from the command line. If you're thinking more along the lines of testing of workflows and running them in test cases, we do have that functionality as well in terms of evaluators that allow us to basically run a workflow 1,000 different times, but with all the different configuration paths, and make sure that they all check out and match what they need to, or match what data should be flowing. So, I'm not really sure where the question's heading, but that could be
Yeah,
one of
let
the
me project some additional detail that maybe the questioner wasn't asking. But so the first part is, can we invoke a workflow from the command line? And I think the answer was yes. The second part really might be about how workflow is deployed. So the workflow is not portable in that I could move the whole workflow to my computer and execute it from my command line, because Savigent is a server. Is that a true statement?
So there's a few different pieces. Let me jump into this. I think that'll help answer a little bit. So in this particular case, we just have this one virtual machine that I'm on connected, right? No demo here. But what you can end up doing is you can add different servers as nodes into the system. So you might have it set up such that you could add your system to this server, and that way it's part of this collection of nodes that run as part of Savigent. But you would need to have that Savigent software still installed on your computer or whatever other server to be able to add it to as a node, if that makes sense.
It does to me, but maybe just for clarity, let's talk a little bit more about deployment. And I think the thing we're contrasting to is something like a workflow that I might put together on my own computer versus something that's running as a somewhat stateful service that's available to manufacturing execution at any time. So you said I could create a node, and that node could be my own workstation, and I might use that for debugging. But for a manufacturer, if I turn off my laptop at the end of the day, that node is no longer available to run workflows. So how do your customers typically deploy a scaled workflow solution?
Sure. So Savigent has, and I'll let Mark talk a little bit too. But Savigent has the capability to scale and load balance. So let's say for a particular very busy facility, they might have 2 or 3 Savigent servers that work together. And I might have multiple copies of my engines and workflows deployed. And if a particular node is busy, the system will automatically detect that and say, okay, this one's busy. I'll run the workflow, or I'll run the connector or engine here on this other system that has more bandwidth. So we have that load balancing capability there built inside of the deployment as well. I don't know, Mark, if you wanted to add anything there.
Yeah, I would also separate the notion from kind of the development and testing away from kind of publishing runtime to a production server, right? So we can have central development areas or even decentralized development areas that publish assets back to a common runtime server to actually execute them. So there's a bit of flexibility in kind of how we approach that, but I don't know, does that answer where you were headed, Jonathan?
I think so.
So you
All
could use your local machine to actually create the workflow, test the workflow, right? Modify the workflow. And when you're ready to promote that from a production perspective, publish it up to the server and move that runtime version of that and execute.
Right. But I think the key thing there is your customers have a server that they run on, that it's a persistent resource, or
from a manufacturing perspective, yeah.
Okay, BPEL, which I had to Google, business process execution language. Is that something you support?
So I think that is, if I recall, that's around kind of web service based XML.
Yeah, I think it's web service-based execution. But
Yeah, again, I think, in this case, I would end up using the engine designer to connect and translate and move that data to and from the workflow through an engine that I would create. So because we have that flexibility inside of Engine Designer, where I can use all those programmable agents, which give me access to load external DLLs or to write script code and just, I don't know if I mentioned it earlier, but there isn't a kind of a secret language that's used there. That's just Microsoft C# that's used inside of those programmable agents. So that can be used to load those external DLLs and information into Savigent and interact with other systems.
how would I call something that's not written in C#? Let's say I have a awesome Python script I want to execute.
So I think there'd be a couple different ways to tackle that. I guess a lot of communications nowadays, typically use like a web service communication. So if that Python script or that Python program that you wrote had an external way to trigger it, or an API that we could access that way through web services, I think that would be one way. We could take that one and we could get back to you as well on some of that.
It would be possible as well to wrap the invocation in C# and execute it locally from your C#, right?
Yeah, I mean, you do have the ability to do, almost most of what you see inside of Visual Studio inside of one of those C# scripter agents, since you can add the references and you can, when you're in there, you can, as you mentioned, put a wrapper around things, call those different code segments as needed. So yeah, it's definitely a possibility. Engines will end up kind of running in their own little app domain too, so it won't affect the performance the same way you might think, and something else might. So if I show you real quick in here, you'll see that, here's all our engines. I think we're running about 4 different engines on this system. Each of them will show up as a separate process here. So when you set up that engine that you're talking about, it could run in its own app domain as well.
Excellent. Same question, but for a PowerShell script?
Yeah, I think kind of the same answer for that. So you could wrap that up and call that from inside of your programmable agents that you have.
Yeah, really the programmable agents let me do pretty much anything I could do from code.
Yeah, right. So anything that you could do from a C# library, you could do from there.
What operating systems can I run Savigent on?
So it's a Windows-based technology. So I don't have the list in front of me, but I think it is Server 2012 and any of the Windows 7 and later OSs. You need to have the .NET 4.5 installed as well for running the Savigent application.
All right. Well, we're almost out of time. I think the final set of questions people will want to know is, first of all, how do they get access to Savigent as part of their project? And I'll take that one. Projects that want to use workflow can. It's part of the platform that will be available to projects and to SMICs as part of your membership. Once a project is complete, if it goes into commercial production, the the ongoing pricing will be negotiated, but during your project, this is a tool that's available to you. And then the other commonly asked question, and I think it'll be asked more after today's intro, is maybe for Mark, how do potential users get more training? If this whet their appetite and they want to learn more about it, what kinds of resources are available other than you and I?
Well, since I don't have the Vulkan mind meld technology to just kind of plug in and hook up to Jesse, we'll definitely make the full training available. We're working on publishing the training curriculum out to the website, and for those who actually want to take the class, we'll find a way to get you the training.
All right. Well, I think that concludes our time today and an incredible set of material. Thank you, Mark and Jesse, for your participation and your instruction. Thank you, everyone who joined. This recording will be made available probably within a couple days on the CESMII website. And if your question went unanswered today, which I think we got them all, feel free to email us and we'll try to address over email.
And we'll also send the deck out for you, Jonathan, that you can actually publish as well.
All right. Awesome. Well, thank you very much, Mark, Jesse, and everyone. We'll wish you all a great rest of your day.
Thank you, everyone. Bye.